So find the sixth term from the end of an AP 17, 14, 11, so on so forth to negative 40. So we want to find the sixth term starting from the last. So for that, we know that this is an AP. In fact, it is a decreasing sequence. That means the common difference is, we know that 14 second term minus first term. So 14 minus 17, which is termed to be negative 3. So the common difference is negative 3. And this is a decreasing sequence and we want to find it from the sixth term from the last. So we have a formula for that. Nth term from the n, that is equal to last term minus n minus 1 into d. So we know that last term, that is negative 40. Negative 40 minus n minus 1 multiplied with d. So here n minus 1, we are asked to find the sixth term. So our n will be equal to 6. So negative 40 minus 6 minus 1 multiplied with d, that is negative 3. So we have sixth term from the end, that will be equal to L minus 6 minus 1 into d. So negative 40 minus 5 multiplied with negative 3. So negative 40, negative 40, negative 5 into negative 5 into negative 3, which is equal to negative 15. Negative 15 into negative positive 15. Negative 40 plus 50, which is equal to negative 25. We can go for next one. The sum of 5th and 9th term of an AP is 72 and the sum of 7th and 12th term is 97. Find the AP. So it is given that we have two AP such that the sum of 5th and 9th term, that will gives us 72, and the sum of 7th and 12th term, that is equal to 97. So this implies A5 plus A9, we have A5 plus A9, that is equal to 72. Of course, we have 7th term A7 plus A12, that is equal to 97. We know that A5, I can write A5 as A plus 4D because AN is equal to A plus N minus 1 into D. Here we have, instead of N, we have 5. So 5 minus 1, which is equal to 4. So A plus 4D plus A9. A9 I can write as A plus 8D, that is equal to 72. And the next one, next equation, A7 plus A12. A7 can be written as A plus 6D. A12 can be written as A plus 11D, and that is equal to 97. Now I can solve these two equations. So the first one will be 2a plus 12d, that is equal to 72. Here I have 2a plus 17d, that is equal to 97. Now we have two equations in two variables. A and d are the variables. I am subtracting 1 from 2. From that, I can cancel out my two a's and the resulting will be 5d, 17d minus 12d, which is equal to 5d. 5d, that is equal to 97 minus 72, which is equal to 25. So 5d is equal to 25, that implies d is equal to 25 upon 5, which is equal to 5. Now I am substituting the value of 5 in equation 1. So 2a plus 12d is equal to 72. This was our equation 1. In this I am replacing d with 5. From that I can find the value of a. So 12a plus 2a plus 12 multiplied with 5, which is equal to 60. So 2a plus 60, that is equal to 72. Now 2a is equal to 72 minus 60. So that is equal to 12. 2a is equal to 12, which implies a is equal to 6. So first term will be equal to 6 and the next term, that will be second term will be plus common difference. We have common difference is equal to 5. So 6 plus 5, which is equal to 11, that will be our second term, and the third term will be 11 plus 5, that is equal to 16. So we can form an AP 6, 11, 16, 21, 26, so on so forth. Let's see the next one. Which term of the arithmetic progression 5, 15, 24, 25, so on so forth will be 130 more than its 31st term? Here they are given as a sequence. The sequence is repeating with 5, 15, 25, so on so forth. So we have common difference is equal to second term minus first term, that will be 10, and our first term, that is 5. They were asked to find which term of this arithmetic progression AP will be 130 more than its 31st term. So for that, firstly I am finding my 31st term. So A31, that will be equal to A31, that will be equal to A plus 31 minus 1 into D. So which implies A plus 30D. a plus 30d. That will be my a30 first term. Of course, I know the value of a and d. My a will be equal to 5 and d is equal to 10. So which implies a31 is equal to 5 plus 30 multiplied with 10, which implies my 31st term, that is equal to 305. Now they are asked to find, we want to find 130 more than this term, right? We want to find what is that n. For that, I am adding 305 with which number? 130. Okay, so an is equal to 130 plus a31. So an, that is equal to a plus n minus 1 into d, that is equal to 130 plus 305. Of course, we know everyone here, we know a, we know d, we want to find the value of n. So the value of a, that will be equal to 5 plus d is equal to 10. So 10 multiplied with n minus 1, which is equal to 435, because 305 plus 130. So which is equal to 10 multiplied with n minus 1, that is equal to 430. I can transpose this 5 to over here. So 435 minus 5, which is equal to 430. So 10 multiplied with n minus 1, that will be equal to 430, which implies n minus 1 is equal to 43. So n minus 1 is equal to 43. N is equal to 43. This minus 1, when it moves to the side, turns to be positive 1. So 43 minus 1 plus 1, that is equal to 44. Next we can go for next one. How many numbers of 2 digits are divisible by 7? We want to find the multiples of 7 that are, we want to find the multiples of 7 up that numbers must be in 2-digit form. Okay, so is 7 included in this set? No, because 7, it's a multiple of 7, but still it is not a 2-digit number. So I am going for the next multiple, that is 14. Of course, I can add 14 in my sequence because 14 is divisible by 7 and 14 is a 2-digit number. Now I go for the last term. Of course, I am not bad for 100 because 100 is a 3-digit number. I will be coming down from 100. So 99, it's not divisible by 7. 98, of course, 98 is divisible by 7. So I have my first term as 14 and last term, that is equal to 98. So I have first, I will be getting a sequence as 14, 21, 28, so on and so forth up to 98. Now we want to find the value of n because we know a here, we know the last term and we know the common difference. So we can find the nth term using our formula an is equal to a plus n minus 1 into d, and an here 98 will play the role of an. So an is equal to a plus n minus 1 into d. 14 is equal to 14 plus n minus 1 multiplied with d, which is equal to 7, that is equal to 98. So on further simplification, I will be having 14 plus, I am multiplying this n throughout the bracket. So 7 multiplied with n, which is 7n minus 7. So 14 plus 7n minus 7, that is 14 minus 7, that is equal to 7. 7 plus 7n, that is equal to 98. Which implies when I am transposing here, we have 14 minus 7, which is 7. So when I move this 7 over to here, this turned to be negative 7. So 7n is equal to 98 minus 7. So 7n is equal to 91, n is equal to 91 upon 7, that is equal to 13.